Assalamualaikum everyone. I'm Abdullah Tamim. I'm a third year student of Computer Science and Engineering at Arsenal University of Science and Technology. So today I'm going to present my project here, which is a legal reg assistant. So we all know that in our country we are not very well taught about law and our legal rights in our school and colleges and academic activities. So here we try to build a rag project which will help people understand law and different kinds of legal rights which they ask. In simple manner, the LLM will answer those questions. So our idea is to build a retrieval augmented system. So we wanna retrieve the most relevant law sections. If user so suppose if user ask about give me this section from this act, mm, the rag will the retrieve that from our vector database. So here we can see in the monitor, we have to scrape different kinds of data from different kinds of governments and others websites. Whereas example, we have scraped data from this BD law website. Here we can see we have separated different kinds of information like act name, act number. If you go down, we have also separated the document type, which is law cause. This is from government website. If we scrape from others website, like there are different kinds of website who write about law, then that will be blog here. Language is English. Active means the law is currently active, and different kinds of metadata. These are used for specific query. So we have used Qrent as our vector database as example. Where we can see a point which is stored. These are our metadata we have separated from normal text, and this is the raw text which is stored here. So we have used three different kinds of embeddings as so that we can use a hybrid search, which is very efficient when cause we are trying to give LLM as much as we can information as we can, relevant information we want to give to the LLM, so that LLM can produce a good answer with those. LLM will only use those retrieved text. He will not use his own knowledge or other thoughts of his own. So if we here so we have used LangGraph, LangChain for our rack project. If we want to see the workflow, we have an image of our LangGraph. Here we can see different kinds of nodes, some of their. So first of all, what the user query that goes to this node as add user message. Then if we are trying to be consistent with the chat, so if the we have condition like if the there are if the user suppose user ask three questions, then we will summarize those, and the AI response of those related queries, and store them. First of all, the query will go to is legal scope node. This will check if the query is related to law or legal issues. If it's not, then simply it will go to the handle out of legal scope. Here we didn't here, here we use the LLM to get to know about if the query is related to law. Here in the handle out of legal scope, it just send a predefined message like I can't answer those questions. uh, but if the question is related to law, then it will go to the interpret query actions. Here we can see there are three different nodes. So we use conditional age here. So suppose the user is user is in a problem and he's asking for a lawyer. The LLM will understand that the user is asking for a lawyer and he will suggest. So here we have stored we have stored some lawyer information in our MongoDB database. Here the identify lawyer type, the query will come at this node, and this here we have used an LLM who we which will try to understand what kind of specialized lawyer the user is needed. Then it will send the the type of the lawyer to find lawyers node, and in this node we will query in our MongoDB to fetch the related lawyers. Second, second specific law. If a user asks specific law, like he may ask, give me the sixth sixth section of a law, then the LLM will understand that he is asking for a specific law. Then he will return what the user is asking. Like if he is asking section 5, he will return a JSON. He will return a JSON object like section 5 and act name this or that. So this JSON will then go to the metadata base to retrieval this node. Here earlier we have seen that there are multiple metadata we have saved in our Qdrant client. So here we will filter out with the act name, act number, or section number, etc., and then return the answer to the user. And the other node, which is doc retrieval. So suppose this is not about a specific law, this is something in general about know something, like what will be the punishment for something if I do, what will be the remedy, what can I do, what is my legal right. Then it will go to the doc retrieval. Here we will use the hybrid search in this node, and we will collect the most related data from our Kindle and give that to the LLM, and then LLM will create an answer from that. That's our line graph. So we have three so each text is embedded in three different embeddings, like this. So we have used dense embedding, sparse embedding, and late embedding to do a hybrid search. Next, if we want to see, so this is our rack project. This is our nodes. So on each the node which called LLM, there are different kinds of prompt. We have tried to create very quite good prompt. so that the AI can understand. Though the response vary on the LLM LLM that we used, like DeepSeek may return one thing, then OpenAI may return the other thing. This happens different times, so we might get different answer from the LLM. For that reason, the final answer may vary. Here we can see one prompt for the identify lawyer type interpret query. So here we try to understand what type of query is that. Is it a specific law, or we have to do a semantic search, hybrid search, like that, or the user is trying to find a lawyer. Here is there is legal scope. So finally we build the graph and made a fast API endpoint where we can where user can ask the query and we will send the answer. Here is the graph. So for backend we have used like Java. Here is a proxy controller. Here we can see the fast API. The backend is calling fast API. So we have deployed the React project and our Java project in render, and the front end, which is created with React, is deployed on Vercel. So on backend we don't have many work, but here we have a chat controller, because we wanna save each chat of a user so that he can view them later. This is a proxy controller. This is a user controller. User must sign in before he start chat. He wanna chat with our project. We have used JWT auth. This is our chat service. Where all the function goes. Now this is our React app. We don't have many pages. We just where user can 3 pages: sign in, sign up page, and a chat page. This 3 page: sign in, sign up. So now if I want to show my project about, like here I asked about punishment of murder, and the answer I get here is this. So yeah, we can create multiple sessions, like here, new chat. We can see 3 different kinds of sessions. 3 different session. We can also delete session, and so we have also used Langsmith, which helps us understand about how the query is going from node to node. Like if there is an error, just understand. Sorry about that. I'm sorry, the net is not working properly. So here we can see, if we ask out of legal question, he will answer like that. And sorry about the net issue. So here my teammate might have asked a question, which is how to file a case, and we can see is a legal scope. It passed. Yes, it's a legal scope. And condition to be the dog retrieval. Yes, we have to do a semantic search, and then finally LLM. We get our answer. We can also see. Yeah, I'm sorry that I'm showing you here. Let's go. So this question. So here, yes, here's a funny problem. The user is asking about he's having a trouble with his uncle about the property, and he's asking for a lawyer. He also lives in Dhaka. Here, the final answer is yes. Here is some, and this is coming from our MongoDB. Actually, we have set some lawyer's information here. I can show you some other questions, but yeah, sorry for the inconvenience.